Hey guys, today we're going to do notes over dimensional change, and let's read this together. The ratio of any two corresponding lengths in two similar geometric figures is called the scale factor. So what we mean by that is if you have two rectangles that are similar, if this side is 3 and its corresponding side on the other rectangle is 2, you're always going to do, when we do scale factor, we put the new side over the old side. And so in this case, it would end up being 2 over 3. Notice that it got smaller. So if this scale factor is less than 1, between 0 and 1, it got smaller. If it's bigger than 1, then it got bigger. So if we start off with a scale factor of 2/3, to get the ratio of the areas, you're going to take the square of that scale factor. Sorry, this should say scale factor. The ratio of the volumes of the two figures is going to be the cube of that scale factor. So if this has a ratio of A over B, then the area ratio will be A squared over B squared, and the volume ratio will be A cubed over B cubed. Okay, so it's easy if you've got the scale factor to start with, because all you have to do is to find the area ratio, you're going to do 2 squared over 3 squared, which ends up being 4/9. If you do the volume ratio, you take that scale factor and you cube it. So that gives me 8 over 27. So if you take the areas of those two rectangles, they should simplify to have a ratio of 4 over 9. If you take the volume of, say, a rectangular prism, their volume ratio will simplify to be 8 over 27. All right, let's say we start with the ratio of the areas. So we wrote over here, you always want to make sure you reduce the fractions first. We think of home base as the scale factor. You always have to go back to home base before you can find the ratio of the area or the ratio of the volumes. So if we start off with the area ratio, we've got to go back here before we can get to the volume ratio. And remember, this was A squared over B squared. So to go backwards, you have to take the square root. So the square root of 4 over the square root of 25 would end up being 2/5. And that's my scale factor. Now we can take that scale factor and find the volume ratio. So we can do 2 cubed over 5 cubed, which is 8 over 125. Okay, next we've got the volume ratio. So we've got to go all the way back here to home base. Remember, this was A cubed over B cubed, so to get the scale factor, you have to take the cube root of that. So the cube root of 27 over the cube root of 64, which ends up to being 3 over 4. In your calculator, if you're not sure how to take the cube root of a number, you can hit Math and option number 4. That'll let you take the cube root of a number. And you can just go ahead and type in 27 over 64 and it'll simplify to be 3/4 for you. Now we can figure out the ratio of the areas. So you take that scale factor and you square it. So 3 squared over 4 squared ends up being 9 over 16. All right, let's practice that a little bit. Okay, on this first example, it's asking us to find what is the ratio of the height of the larger cone to the height of the smaller cone. So it'd be really nice if we had the height of both of those figures, because that's what they're asking us for. We've got the height of the bigger one, it's 12. We don't have the height of the smaller one. We can do Pythagorean theorem to figure it though. I'm going to draw this figure like this. If this is 2.5, this will also be 2.5. And when you draw that height, it cuts this, that ends up being the diameter of that cone, but it cuts it into 2 equal parts of 2 and 2. And now you can do the Pythagorean theorem to figure out the height. So you can do 2 squared plus h squared equals 2.5 squared. That's 4 plus h squared equals 6.25. Subtract 4, so you get 2.25. And so h equals 1.5. So when you do the ratio of the heights, you're going to do, it tells you here, it wants the height of the larger cone to the height of the smaller cone. So you're doing large. We can use a colon to show that too. You're doing large to small. Another way to write it would be the large one on top in a fraction with the small on the bottom. So the large height is 12, the small height is 1.5. And if you want to simplify that, you can plug it in the calculator and it'll tell you it's just 8/1. So this is the simplified. Remember, we always want to simplify it. Okay, so honestly, that was the harder way to work that problem. If you've got similar figures, that means every dimension was changed by the same amount. So I could have just taken the radius and done a ratio of the radii. That would be the same as the ratio of the heights. So the radius of the big one was 16. The radius of the smaller one was 2. So I could have done 16/2, which also simplifies to be 8/1. If those figures are similar, then the radius ratio should be the same as the height ratio. So just another option. Okay, now it wants us to find the ratio of the surface areas. So remember, to get the area ratio, that's going to be the side ratio squared. So we're going to take 8/1 and we're going to square it. And when you square a fraction, you square the top and the bottom, so it'll be 64/1. And that will be your area ratio. Okay, on part C, it says if the volume of the larger cone is 6,144 cubic meters, what is the volume of the smaller cone? So we need to know, to find the volume, you have to have a volume ratio. I'm going to write that. To find the volume, you need a volume ratio. Well, you need to use a volume ratio. And to get that, remember, to get a volume ratio, it's the same thing as the side ratio cubed. So your side ratio was 8/1, and you're going to cube that. So that gives me 512/1. All right, now we can set up a proportion with that volume ratio. So 512/1 should equal, it says the larger cone, remember the larger number is on top, so we're going to put that on top. And we're going to try to figure out the volume of the smaller cone, so it goes on the bottom. And now we can cross multiply and solve. Anytime you have a proportion, you have one fraction equal to one fraction, you can cross multiply. So that gives me 512x equals, these two cross multiplied gives me 6,144. Divide by 512 and you're going to get 12. And this is meters cubed. And that's the volume of the smaller one. If I type into my calculator 6,144 divided by 12, it should give me 512 because it simplifies to be that. All right, let's do another one. Okay, on the next one, they want us to find the similarity ratio, which is the same thing as the scale factor, of two squares with areas of 225 and 400. So first, I can set up an area ratio because I have the areas. It's going to be 225/400. Okay, so I need to simplify first. So if you want to simplify that, you can always type in, if you type in alpha y equals in your calculator and then put that into the fraction and hit enter, it's going to simplify for you. So this simplifies to be 9/16, so this is my area ratio. 9/16 is. So if I want to get the side ratio, I'm going to have to take the square root of that. So square root of 9 over the square root of 16. That's going to give me 3/4, and that equals the side ratio, which is what this question is asking me for. So my side ratio is 3/4. Okay, what is the volume ratio of two similar figures with an area of 36 and 100? So we're trying to find the volume ratio. We've got the a squared over b squared. We need to figure out a cubed over b cubed. But to get there, we have to go back to the side ratio. So we have to go to this before we can go to this. All right, so the area ratio is 36/100, which simplifies to be 9/25. Okay, so that's our area ratio. So to go back to the side ratio, I'll take the square root of 9 over the square root of 25, which is 3/5. Now, to get the volume ratio, that's going to be the side ratio cubed. Oh, I don't know why I put that as a fraction, sorry. Side ratio cubed, so 3/5 will be cubed. So you cube the top and the bottom, that'll be 27 over 125. Now that I know, well, that's what I need to know. I need to know the volume ratio. It's 27 over 125. That is the volume ratio. All right, let's do another one. Okay, on number 4, they say the volume of two similar cones is 1024 pi and 54 pi. So we can set up a volume ratio. And it wants us to find the ratio of the radii. These are sides, or they're thought of as sides. They're one-dimensional parts. And so we can either set up a side ratio or a scale factor. They're the same thing. So that's what we're looking for. All right, so the volume ratio, I'm going to abbreviate VR for volume ratio. I'm going to put the bigger one on top, 1024 pi over 54 pi. Now those pi's are going to cancel out, and so you end up with, when you simplify that, 512 over 27. So that's my volume ratio. Okay, so if we want to change that to a side ratio, we're going to take, remember, we've got side ratio. Why did I put an equal sign? Sorry. You've got side ratio, and then you've got area ratio, and then you've got volume ratio. So if you want to go from volume ratio to side ratio, you have to take the cube root. So the cube root of 512 over the cube root of 27. That's going to be 8 over 3. And that's my side ratio. I didn't make that look very much like an 8. Sorry about that. So 8 over 3 is my side ratio. So again, remember to take the cube root. You hit math on your calculator and option number 4. Okay, let's do number 5. If the smaller cone in number 4 above has a surface area of 45 units, what is the surface area of the second cone? So if I'm trying to find surface area, I have to have an area ratio. So again, I've got the side ratio. I need to convert it to the area ratio. So my side ratio is 8 over 3. If I want to change it to an area ratio, I have to square it. So that's going to be 64 over 9. Now that I have the area ratio, now I can change it to be, hang on. Okay, so now that I have the area ratio, I need to set up a proportion. So we've got our area ratio, 64 over 9, and it tells me the smaller cone is 45 units. So my smaller number is the 9. I need to put the 45 where that is. And I'm going to find the surface area of the larger one, so I'll put an X here. Because we have one fraction equal to one fraction, I can cross multiply. So I'll multiply those two together, and I'll multiply those two together. And that gives me 9x equals 2,880. And then when you divide by 9, you're going to get 320. So the surface area of the larger cone is 320 units squared. All right, let's do the next one. For some reason, both of these are number 5. That was throwing me off a while ago. Sorry. I didn't mean for that to happen. Sorry about that. All right, so on the next number 5. The surface area of two similar cylinders is 150 centimeters squared and 24 centimeters squared. So I've got two surface areas. I can set up an area ratio. I'm going to do the first one over the second one. And when you simplify that, you get 25 over 4. Okay. Now then, if the volume of the larger cylinder is 375, what is the volume ratio of the smaller cylinder? So remember, we start off with our side ratio, and then we have the area ratio, and then we have the volume ratio. If I'm trying to find volume, I need a volume ratio. So right now I've got the area ratio, and I need to convert it back to home base, make it a side ratio, so that then I can convert that to the volume ratio. So to get the side ratio, I'm going to take the square root of 25 over the square root of 4, and that gives me 5/2. Now that I have the side ratio, I need a volume ratio. So I'll take that side ratio, and I'm going to cube it. So I get 125 over 8. Now I can set up a proportion with that volume ratio. So if you're trying to find volume, you have to use the volume ratio. So 125 over 8, it tells me the volume of the larger cylinder is 375, so it goes on top where the bigger number is. And I'm trying to find the volume of the smaller one, so x is going to go there. Because I have one fraction equal to one fraction, I can cross multiply. So 125x equals what these two cross multiply to be, which is 3,000. Okay, now we can divide by 125 and we get 24. And our units are centimeters cubed. And that's my answer. All right, next one. Okay, on the next one, they give me the scale factor. They say the scale factor of prism A to prism B. So they tell me it's 3:1. That means that A is on top and B is on the bottom, just so you know. Okay, it tells me the surface area of prism A is 1,503. All right, so this is a side ratio, 3:1. So the area ratio will be 3/1 squared, which is 9/1. And then the volume ratio will be that 3/1 cubed, which is 27/1. All right, so this wants me to find the surface area and volume of prism B. So if I'm going to find the surface area, I'm going to abbreviate SA for surface area. You have to use the area ratio. So 9/1 will equal, it tells me prism A surface area. Remember, we have A on top and B on the bottom. So prism A has a surface area of 1,503, and we're trying to find the surface area on prism B. Now that we have a one fraction equal to one fraction, I can cross multiply. So 9x equals 1,503. And then divide that by 9, and you're going to get 167. And that's meters squared. So that's the surface area. Now we can do the volume. So I have to use the volume ratio. So I'm going to do 27/1 equals, the volume of prism A is 3,429 over x. Because we have one fraction equal to one fraction, I can cross multiply. So 27x equals 3,429. And then divide by 27, and we get 127 meters cubed. And that's my answer. Okay, number 7. We have two similar cylindrical cans, and they have a scale factor of 2:3. So this is my side ratio, 2:3. The area ratio will be that side ratio squared, so it's going to be 4/9. The volume ratio will be that side ratio, cubed, so it will be 8/27. Okay, so again, that was the side ratio. Okay, so the smaller can has a surface area of 308 pi and a volume of 735 pi. That's the smaller can. Find the area ratio, or find the surface area and volume of the larger can. All right, so I'm going to find the surface area first. I'm going to use the area ratio, which is 4/9. The smaller number's on top, and they gave me the surface area of the smaller one. They said it was 308 pi. And then I'm trying to find the surface area of the other one. I'm just going to ignore the pi for a little bit. Well, not really ignore it. Let's cross multiply. So we get 4x equals, I'm going to multiply those two together, and I get I'm just going to write it out like this. 9 times 308 pi. All right, I'm going to divide both sides by 4. And so basically when you multiply 9 times 308 and you divide by 4, you get 693. And now I'll attach that pi to it. So it's 693 inches squared. All right, the volume, if you're trying to figure out volume, you're going to have to use the volume ratio. So my volume ratio is 8/27. The smaller can has a volume of 735 pi cubic inches. I'm trying to find the larger one. So cross multiply, I get 8x equals 27 times 735 pi. So if I multiply 27 times 735 and then divide by that 8, I get 2,480.625. And then I'm going to attach that pi to it, inches cubed. And that's the volume of the larger one. All right, one more. Okay, on this last one, two similar spheres have volumes of 16 pi and 432 pi. So I could set up a volume ratio, which is going to be 16 pi over 432 pi. If I were to simplify that, the pi's will cancel and I'm left with 1/27. So that's my volume ratio. So it says the larger sphere has a surface area of 72 pi. Find the surface area of the smaller. So remember, you've got side ratio, you've got area ratio, and you've got volume ratio. We've got to make the volume ratio go back to the side ratio so that then we can figure out the area ratio. So to go from volume ratio to side ratio, I'm going to take the cube root of the top and the cube root of the bottom. And that's going to be 1/3. So now I can convert that to an area ratio because the area ratio will take that side ratio and square it. So that gives me 1/9. Now that I have the area ratio, I can set up a proportion. I can do 1/9 using the area ratio. And that should equal, it says the larger sphere has a surface area of 72 pi. So the larger is going to go on the bottom. And we're trying to figure out the smaller one. And then I'm going to cross multiply. So 9x equals 72 pi. Divide by 9. I'm just dividing 72 by 9. And I get 8 with that pi attached. So it's going to be 8 pi, and my units are feet. And since we're talking about area, it's feet squared. All right, that's it for your notes. Thanks, y'all.